خير. السلام عليكم ورحمة الله وبركاته, dear students. First of all, Ramadan Kareem. And today we are continuing with lecture number 21. We will have a small piece of the call and return. We have to finish it, and then we will go directly to the next chapter regarding the representation of floating point numbers on the computer system, which is actually the real representation that represent real numbers on the computer system. First of all, let me share my screen here because I want to discuss the rest of the slides for the chapter of the call and return. I hope you can see my screen. Can you see my screen? Right. We discussed in the last lecture the call and return, and we mentioned that call and return is a very simple two pair of kind of twin instructions. They usually use together. The call instruction allow me to call some subroutine. So you have some section of your code separate from your main code, and this is called the subroutine. And in order to facilitate jumping to that subroutine, you have to use the function call. Call is doing two things. First, it push the current IP address into the stack. This is the first operation. The second operation is it jump to the target address, the IP address, the target IP address, in order to execute the jumping or the calling for the subroutine. At the end of the subroutine, I have to have the other instruction to allow me to return back to where I was. Okay? طبعا I'm not returning to the location of the call instruction. I am returning to the instruction after the call. So since the address is now, IP is stored in the stack, the return instruction is doing also two operations. First, it pops the IP from the stack, and then it will put it into the IP register in order to make or simulate the jumping back to where I have left. The slide number 35, which I'm showing here, actually representing the addressing modes for the call and return. We have two types of call and return. We have what's called the intra-segment call and return, and we have the inter-segment call and return. Intra-segment, I can have a, forget about the short label, we are not using it. We have what's called the near label, the memory addressing mode, and the register. That means the address for the target, similar to the jump instruction, could be either mentioned explicitly in the instruction, which we can call it an direct addressing mode, okay, or it could be stored indirectly in a register, or it could be stored in the memory. All of this is available for the call instruction. Return is return. Return has only one addressing mode. It's just popping and jumping to the new location. We have also what's called the inter-segment. Inter-segment, we call it a far jump. Far jump means I can go outside the code segment. When do I do that? I go outside the code segment. Can I ever go outside the code segment, and how? مش how, why? Can you imagine a scenario that I want to go outside the code segment? مين يقول؟ بالظبط كده. برافو رغد ومها ولبنى وتمارا. Extra segment, we mentioned in the beginning that the extra segment is used to either put some code in it or data in it. So if my subroutine is stored in the extra segment, I have to do a far jump, not a near jump. What a far jump means? Far jump means I want to go outside the code segment. Going outside the code segment means I want to change A في المايكروبروسيسور. يعني عشان in order to perform a far call, what kind of registers needs to be changed in the microprocessor؟ مين شاطر يقول لي؟ بالظبط كده، برافو يا محمد ويا مها. I need to change both the IP and the CS, because IP and CS now has the values in the code segment. Right now I want to do a far jump. I want to go to a new segment. So CS register should change its value to take the value of mean of the ES register. لو أنا عايز jump للES register. Okay. وكذلك IP, the IP needs to change its value to take the value of mean of the new location inside the extra segment. That's why it's called the inter segment. It's called inter segment or far jump. So for the far jump, how many push the call needs to do in the segment? How many push? Is one push enough, or I have to do two pushes? I have to do two pushes. I need to push the IP address and I wanted to push the CS value. So two pushes are being done في الفار jump. Okay, this is an example of a indirect or a memory addressing mode call. Okay, as you can see here, I am accessing the memory, the data segment to get mean. يبقى I am using the DI register to identify an offset in the data segment. I am using the DS DI to get mean to get address of the far jump. الفار jump ديت اوكي المفروض تديني مين؟ two addresses. Okay, address for the IP or address for the CS. Okay, so what I will retrieve from the memory will be the new segment and offset for this code instruction. يبقى before I retrieve this data from the data segment بعمل ايه؟ I have to push the IP register and the current CS register into the stack. Then this call will go and retrieve from the data segment at the location DSDI two values, 4 bytes, 2 bytes for the IP, 2 bytes for the CS, and populate the CS and IP with those new values. So I can simulate or can jump or emulating or performing mean a far jump through this instruction. تمام؟ Agree? طيب. Since I'm storing into the stack now, okay, for the far jump, for the far jump, I'm storing for the far jump, I'm storing 4 bytes into the stack. I'm doing 2 pushes, صح? In which order the data, the IP and the CS will be pushed into the stack? Which order? First of all, why the order؟ تمام؟ لا مش مسألة، ما طبعا in the leaf order، لا أنا بتكلم على الأوردر between الاي بي والسي اس. يعني أنا دلوقتي I am pushing IP and CS inside the stack، صح؟ مش كده؟ I'm pushing mean how many values? I'm pushing 4 bytes. What is the order of those 4 bytes to be pushed into the stack? Okay? الليف دوت ما بين البوش والبوب. اوكي، الليف ما بين البوش والبوب. انا بتكلم في البوش، عمليه البوش لوحدها. عمليه البوش يعني ايه لو؟ لا ما اسموش لو. ايوه كده، ما قالت اهي little Indian order. مظبوط كده. Little Indian order. That means okay the low order bytes of the stack. انا عندي 4 bytes in the stack needs to receive the IP address and the CS values. Okay, in which order? In the little Indian order. That means okay the addresses with the low address will take the low byte of IP, then the high byte of the IP, and then the high order 2 bytes will take the low order of the CS and the high order of the CS. If I'm using the little Indian order to push the IP and the CS inside the stack. Okay, by the way, this is for the far jump or for the far call, and also for the near. النير برضو I want to push مين IP. طب IP ده كام بايتس؟ How many bytes for the IP? How many bytes for the IP؟ 2. How they will be pushed into the stack حتى في النير jump، في النير level، في النير call. They will be pushed into the stack فين؟ بالايه؟ بالليتل Indian order. تمام كده؟ يبقى سواء far jump or near jump or far call or near call I am using مين؟ I am using the little Indian order. طيب let us demonstrate this. تمام؟ Let us demonstrate this. Assuming that I have the current setup as it is shown here in the slide. Can you see the slide? Here I'm demonstrating to you to make the idea clear for you what's going on inside the machine for the call. Assuming that I have the current instruction. طبعا زي ما احنا متعودين بنعمل ايه؟ تعالوا كده insert وناخد لنا text box ونحط هنا فين المايكرو بروسيسور now is executing what? CS double dot IP. الكرنت CS double dot IP. تمام؟ طيب CS double dot IP هنا. Let me just reduce the size a little bit here. Okay, now what's the value of CS IP? CS IP adding مين؟ adding ال IP to the CS يديني كام؟ يديني ايه؟ 0 1 A 0 0 بالهكس. correct؟ مش كده ولا ايه؟ يبقى this is the current instruction to be executed. المايكرو بروسيسور هيعمل ايه؟ fetch decode execute. هيروح يفتش الانستراكشن. This instruction is to be fetched is how many bytes of the call instruction here as it is shown in the example. Okay, طبعا احنا هنا ايه 3 bytes لان انا I highlighted with the color with the yellow color. طبعا من الانستراكشن نفسها you cannot know, you cannot tell. Okay, it is called QS. ايه QS دي يا عم؟ What is QS? QS is a label. اهو تحت اهو. Okay, so inside my code segment I have label QS. I put it in front of one of the instructions. Okay, to indicate that this is the starting point of my subroutine. يبقى subroutine is starting at location QS. And here in my main body of the code, I have the call QS. Okay, ال QS دي الفاليو بتاعتها ايه؟ يبقى ال QS representing ايه؟ representing an IP address. صح؟ What is the value of QS? Value of QS, huh? What's the value of QS? The value of QS is value of QS بكام؟ مين شاطر يقول لي value of QS؟ هعرف ال value of QS منين؟ من هنا بالinstruction. الinstruction is 3 bytes. The first byte is for the opcode. يبقى الopcode for the call is 8E. تمام؟ طيب واللي جاي بعدها ايه؟ It should be the operand of the instruction. The operand of the call instruction is the target address, which is an IP address. This is a near or a far call. دي نير ولا فار كول؟ دي نير كول. يبقى شايله، يبقى الكول انستراكشن كاري اونلي ذا اي بي، ذا نيو اي بي ادرس. يبقى النيو اي بي الكيو اس اللي هو النيو اي بي ادرس، new IP is provided in the instruction as the hex number 0D45 كده. اوكي. يبقى what the microprocessor is fetching these 3 bytes knowing the new IP address. Okay. And also, and so what's the call should do؟ قلنا do الكول هتعمل ايه؟ will do 2 operations. يبقى after fetching، تمام، it will a decode. تمام، هتعرف ان دي كول near call والنيو اي بي ادرس فين؟ 54D0. طب جميل قوي. what the microprocessor would do؟ هيعمل ايه المايكرو بروسيسور؟ اوكي. الكول اول حاجه هتعملها ايه؟ اتفقنا؟ الكول اول حاجه هتعملها ايه؟ what's the first thing the call will do؟ يا شباب الكول هتعمل ايه؟ الكول the first thing the call is doing is to store, is to push the old IP address into the stack. طيب which IP address بقى؟ What is the IP address that the call instruction should push into the stack? The IP address for the instruction right after the call. يبقى الاي بالظبط كده يا عبد العزيز. The IP address for this physical. Okay, which is basically the IP address of the call plus 3. مش كده ولا ايه؟ تمام؟ يبقى since the call instruction is 3 bytes يبقى ال IP address of the call plus 3 representing the IP after the stack. يبقى خلينا نقولها هنا. Let's take one box here. Okay. يبقى ال IP after call يساوي ايه بقى؟ equals to ال IP of the call plus 3. مقتنعين ولا مش مقتنعين؟ ليه plus 3؟ لأن الكول نفسها 3. Shall I push the IP of the call into the top of the stack؟ هيحصل ايه if I pushed؟ What will happen if I pushed the IP of the call into the stack؟ بالظبط كده infinite loop. ليه؟ لأن when I retrieve after the return address I will go again to the call. Okay, so I keep calling, returning forever. What I wanted to push into the top of the stack is the address after the call, and the address after the call is actually IP of the call plus 3 اللي هو بكام هنا بقى؟ equals to احنا عندنا الاي بي اهو يبقى 0 A 0 3 بالهكسا. يبقى this is the address that should be pushed into the stack. مش كده ولا ايه؟ صح؟ How can I perform pushing؟ How can I perform pushing؟ حد فاكر البوش؟ How can I perform push into the stack؟ التوب of the stack التي او اس مشاور على location فاضي ولا is it pointing to a free location or an occupied location؟ The top of the stack is always pointing into a occupied location. So the first thing I wanted to go and do what? I wanted to go and decrement. بالظبط يا هند. decrement مين؟ decrement by 2 لمين؟ decrement what? decrement the SP. برافو. ال SP has the value كام؟ 9540. يبقى SP يبقى I have to do a calculate. يبقى SP okay minus 2 is actually the new top of the stack. Okay, SP minus 2 SP بكام؟ 0459 هيبقى 0457 is the new top of the stack. Okay, so actually I'm shifting the top of the stack from this location to that location. So right now I have I am pointing to two free locations اللي هم مين؟ Okay, can I calculate the top of the stack now? The top of the stack adding SS to new SP. Okay, اللي هو كام بقى؟ Okay, SS is 0300. I will add to it SP minus 2 اللي هو 0457 after the shifting. يديني كام بقى؟ يديني يبقى انا I'm adding فاكرين ولا مش فاكرين؟ 03000 in hexa should be added to mean 00457 in hexa. When I add those together, I end up of pointing where? Pointing to this location. صح كده؟ Okay. Where are the two locations to be now populated by the IP that we calculated above? Those two locations. The physical location 75430 with 85430 are now to carry what? To carry the new the IP after the code, the pushed IP. صح ولا مش صح؟ تمام؟ طيب in which order? In the little Indian order. Everybody is following? طيب اللوكيشن 7543 هياخد will take which 2 bytes of the address after the stack after the call IP after the call اهو. اوكي هنا في ال 75430 هياخد اني فاليو؟ في هنا 2 بايتس اهم 30 و A0. ال 30 تروح فين؟ مظبوط كده ال 30 تيجي هنا. اوكي يبقى 30 will go to the low byte اوكي اللي هو 7545. طيب والاذر بارت اللي هو 0 ايه؟ يروح فين؟ يروح للنكست ادرس. اوكي يبقى right now I simulated a push for the IP after the call into the stack, and I definitely shifted the top of the stack down or decremented to point correctly into the new location. Okay يبقى what other changes will done هنا ال SP دلوقتي بقى مشاور فين؟ على 7540. okay يبقى top of the stack at this location will stack is being carrying the IP after the call. Okay and now I performed the first operation of the call and then I pushed the IP into the stack. Next step, what's the next step? To perform the jump. How can I jump? Simply go and take the new IP address اللي provided in the call instruction اللي هو ال QS اللي هو the value 54D0 وحطها فين؟ في ال IP. برافو. يبقى the IP now will change its value to the value 0D45. Now I did يبقى الكول عملت two things. Push the IP after the call into the stack and jump by changing the IP address to the target address given into the call. Now the microprocessor will go to perform the next instruction, needs to go into its يبقى هو كده الكول خلصت. The call finished its job. Okay, so now the microprocessor will go where to execute next. It will go to do fetch. هيفتش منين بقى المرة دي؟ again CS IP صح؟ يبقى it will after finishing the call, it will go to do a CSIP. طيب فين CSIP؟ CSIP معنى كده ان انا اجمع CS. فين CS؟ CS is 01000 بالهكسا will be added to الاي بي دلوقتي بقى بكام؟ 00D45 بالهكسا. When I add those two values, I will get the value 01D45 hexa. يبقى this is the new location for fetching. اللي هو فين يا جميع يا شباب؟ فين يا حلوين؟ اهو اللي هو الليبل QS. Okay. يبقى now the microprocessor will start executing the instruction after the call. No, not after the call. He will execute the instruction, the first instruction in my subroutine. Agree? Make sense? Any questions? Any doubts? يبقى can we see here what the call is doing? بتعمل بلاوي الكول دي. تمام؟ Okay? Agree? We understand the mechanism. We understand what's happening inside the microprocessor to perform a call instruction. تمام؟ يبقى the status of the microprocessor after the call instruction is provided here. How does it know when to return after the call? Where is the return? The microprocessor will continue fetch, decode, execute for the subroutine لغاية إيه بقى؟ Until it find the return. الريتيرن موجودة فين؟ The return exists at the end of the subroutine. Here is the example. I have my main code أهو يا شباب. I have call SQ or QS whatever تمام. And I jumped to the subroutine. Here is my subroutine. At the end of the subroutine, I have mean. I have a subroutine should end with what? Should end with return. So the microprocessor will keep fetch, decode, execute sequentially of the code here until it encounter mean. أول لما يلاقي إيه لغاية لما يلاقي إيه. Once it finds the return, he will go and return. صح؟ مش كده ولا إيه؟ تمام؟ صح؟ So here the return. Let's go and simulate the return. تمام؟ خلاص أنا خلصت الكود بتاعي. الكود بتاعي كان شغال. Okay. I'm running the code until I reach mean. I reach the return. Let's go to simulate the return. ادي الريتيرن. نرجع نعمل نفس اللعبه. اوكي. الاي بي والسي اس اجمع اي بي على سي اس. اجمع اي بي على سي اس. اي بي وسي اس. فين الاي بي؟ 00F80 بالهكسا بلس فين السي اس؟ 01000 صح بالهكسا. نجمع دول يدينا كام؟ equals to يبقى 01F80 بالهكسا. correct? Okay. يبقى here this is a snapshot of the microprocessor at this instruction return. Okay. الريتيرن موجوده فين؟ at the location 08F1. ادي 08F1. يبقى this is where I am. فاهمين يا شباب؟ كلير؟ انا بشرح بالسلو موشن وبشرح كل حاجه بالديتيلز. مش كده ولا ايه؟ في ديتيلز اكتر من كده؟ كل ده بدور على سهل. عايز سهل. هاتولي سهل. ادوني سهل. ادوني الجرعه بسرعه. Here. So here what I am at. Okay, the microprocessor at this, the status of the microprocessor here indicates that I am in that instruction. What is this instruction? It is a return. How many bytes of the instruction? It is only 1 byte. The opcode for the return is a C3. تمام كده؟ When the microprocessor find and return هيعمل ايه؟ 2 operations. What are those 2 operations? What are the 2 operations of the return? What are the 2 operations of the return? Huh? Let's name it. Pop to get where the new IP address, where to jump. يبقى هيبوب فين؟ We'll go to the top of the stack. Where is the top of the stack? حسبناه واحنا في الكود. تمام؟ Okay. The top of the stack at 75430. At pop, what I do, I'm retrieving 2 bytes from the stack and shifting or incrementing the top of the stack to a new location. صح؟ تمام؟ Those 2 bytes will go where? That I'm getting from the stack will go where? The 2 bytes that I'm popping from the stack will go where? Will go where? Will go where? Will go where? Will go to the IP. مش كده؟ تمام؟ يبقى ال IP right now has the value 30A0. Okay? Preparing the microprocessor to execute the instruction right after the code. تمام؟ And what will happen to the SP? SP will change ولا لا؟ صح، هيحصل له ايه؟ increment بكام؟ by 2. يبقى again the SP is incremented by 2 to return to its original location. And right now, the microprocessor have finished the execution of the return, pops the IP, put it into the IP, pops the IP from the stack, the value from the stack, put it into the IP register, and now he is ready to execute the first instruction, okay, after the return, which is not basically the address right here, okay? And next instruction to be executed right now, based on the new value of the IP, is has the address 0A1A0. Okay, and now where the microprocessor will be executing, the microprocessor will execute the instruction after the call. Agree? Make sense? Any questions? Any doubts? We did a full simulation about what is happening inside the microprocessor for both call and return. And here is the status of the microprocessor registers and memory after the return. تمام؟ طيب. Now, okay, this is another instruction, or this is another code actually showing here 2 types of calls. I have this is a near call, and this is how I can write a far call. طبعا الفار call here is stupid. حد يقول لي ليه؟ ليه stupid؟ Stupid لأن هي actually using the CS as the target segment. يبقى ما عملتش حاجة. طب what I am losing from using the far call here؟ مين بقى شاطر ومصحصح يقول لي ايه الخساره اللي اختارها لما استخدم فار كول كده بالمنظر ده؟ The code by the way will execute بالظبط الميموري سبيس ممتاز هايل. فين؟ الميموري اللي انا خسرتها هنا فين؟ في انهي حته اللي خسرتها؟ خسرت ايه كده؟ خسرت سبيس فين؟ خسرت سبيس في الكود سيجمنت. Okay, because this far call is definitely longer than the near call, because this far call will occupy more bytes. Okay, it cannot occupy 3 bytes. It has at least to occupy كام؟ 5 bytes الكول نفسها, because actually it's actually تاني برضو او دي بتقلقني يا هند. Okay, 5 bytes تمام, because the opcode for the call 2 bytes for the IP و 2 bytes for the CS are occupying the code segment. تمام؟ وايه تاني؟ تمام؟ ايه الخساره الثانيه اللي هخسرها؟ what I'm losing here؟ مين شاطر يقول لي؟ مين شاطر يقول لي؟ لا خلاص انا فهمت. ما تهمكوش خلاص. اوكي قولي براحتك. بالظبط كده مها، برافو عليكي. الستاك. Now I am forced during the code execution here I'm actually occupying 4 bytes of the stack instead of 2. مش كده؟ يبقى I'm filling my stack needlessly. تمام؟ ما كنتش محتاج لده. Agree? Make sense? طيب. كله فاهم؟ كله clear؟ آخر slide in this chapter is actually talking about some recommendation. Before you do call and return, okay, remember something. The subroutine that you are calling to may not be written by you. You have a big project and you give each subroutine to one programmer to program, okay? Each programmer will write the code for his subroutine. تمام كده? Okay? You have to make sure that you have, remember something, all of the codes are sharing the same registers, okay? So the programmer who is programming some subroutine should assume that the registers are free or occupied. He cannot assume that the registers are occupied, because if he assumes that the registers are occupied, this will make it difficult for him to write his code. هو مش هيعرف يكتب كود من غير ما الريجسترز تبقى free. صح كده؟ Okay? So it is highly recommended that before you do a call to a subroutine, you have to do what? You have to store the values of the registers inside also the stack. Okay? So it is recommended to push the values of registers into the stack before you have the call, and after you return from the call, you are supposed to do to pop them back from the stack. Okay? In which order back? For pushing and popping? Leave order. Okay? So the first thing that you push into the stack, the last thing that you pop, if you are using the stack to store your data. And this is actually what is happening. The stack in high-level language is not only carrying the address for where to return to, but actually when you call a function, okay, you are in high-level language there are many things that is being. Hello, can you hear me? Many things that is being pushed into the stack, not only the return. Yeah. Hello? Hello, can you hear me? Is the voice clear? طيب تمام. يبقى it is recommended to push things into the stack before you go into the subroutine. Okay, each push is incrementing the SP, and each pop is incrementing it. تمام. Agree? Make sense? Any questions? Any doubts? So we finish the chapter. Okay. Can you see the slides? Can you see the slides? طيب تمام. Okay, so we are done with the chapter 4. Okay, you have to understand the mechanism of call and return. Okay, there is no programming for call and return. يعني لأن مفيش فيها يعني creativity أوي. تمام. ف usually there is no programming problems for the call and return. It is just a call and return for the subroutine. Okay, there is no problems or exercises in programming for call and return. Maybe in the lab, you take it in the lab, but for the theory, we don't have. But I want you to fully understand the mechanism of the call and return, to understand the call and return in general. Okay, and what's happening. طبعا بتيجي صح خديجه لقطتها. الاسئله بتاعت الكول اند ريتيرن بتيجي في المالتيبل تشويس وفي الترو اند فولس. اوكي تمام. اجري ميك سنس. خلاص طيب عملنا شويه تغييرات في السلايدز، خلينا ناخد منها سناب شوت. طيب now we need to move to something completely different and new. We want to start the new chapter. Slide 41 int ثانية واحدة. انت مالكيش دعوه بيها. int stands for interrupt, and we will explain it inshallah in the chapter for the interrupt. What's int and what it is doing. Okay. The style of coding here in the assembly is kind of a little bit, it's an old style of writing the assembly, and we are not using it even in the lab anymore. Okay, so we are using a more advanced way to write the style of the code. So in the lab we never use the int, but we have what's called the exit proc to exit from the code. So it is something similar to this. Exit proc is similar to the int. Okay, it's giving an interrupt. It's interrupting the microprocessor to exit your code. This is actually an indication for where is your code is finishing. Okay, so as you see here, it's returning to DOS. We are not using DOS anymore. So it's an old-fashioned way to finish the code. By the way, it is still used, but now in a more elegant way for the programming. But you don't worry about that right now. We will explain that in the interrupt chapter, inshallah. Tamam? Agree? Sample meter. Yeah, it's int is just an indication that the code is done, the end of the code. This is an indication for the end of the code, no more. Okay, so your code is ending here. Okay, int 21 or int 3, it is indicating that the code is done. You finished your code. It's an indication for where the code ends. Tamam? Tamam? Okay. Let's go by to the next chapter. Number representation. طيب. Can you see my screen? نبدأ بقى في موضوع جديد. ننسى بقى البروجرامينج خالص، وننسى الانستراكشنز، وننسى كل حاجه. لا مش هننساهم يعني عشان عندنا الميد، بس قصدي عايزين نفضي دماغنا تماما من الاسمبلي خالص دلوقتي. We are shifting to a completely new subject, which is the numbering or representing the numbers. Okay. Today, our slides we are presenting something kind of totally new. Okay, I'm not sure if you have come across this before. You definitely touch base on this in the high-level language programming. Okay, what are the data types that you have in the high-level language? What are the data types? When you define your variables, ايوه جميل. int for integer, character character means it is 1 byte. ايوه استنى كده، في حد كده رزعنا حاجتين مهمين. في حاجه اسمها float وحاجه اسمها double. Float and double. And this is actually what we want to talk about today. Okay, the number representation. And here we want to go back to DLD, digital logic design. What are the number representations that you learned in digital logic design? اتعلمتوا ايه في DLD؟ اتعلمنا ايه في DLD؟ اتعلمنا ال unsigned integers، صح كده؟ اتعلمنا ال signed two's complement numbers، اتعلمنا ال sign magnitude. Okay? Those are the three representations for numbers in binary. مش كده؟ Okay? Those are three different methods to represent the decimal numbers in binary. صح؟ Okay? Today we also maybe some of you touch base on what's called the BCD. Okay? خدتوا البي سي دي في دي ولا لا؟ مش كل الدكاتره بتدرسه، طبعا انا بدرس البي سي دي. اوكي؟ يبقى all of those خلاص ما تقلقوش نفسكم قوي بالبي سي دي، تمام؟ اوكي؟ It stands for binary coded decimal. Okay? We will not use it, but it's another representation. You know something؟ يبقى either the binary coding يبقى انا عندي unsigned numbers, signed two's complement, signed magnitude. I stressed that those three at least you have to learn from DLD. If you forget any of those, please go back and review that, because we will need them to learn the new representation of today, which is called the floating point numbers. Okay? The BCD is not that important. The ASCII is not a representation, it's a binary representation, but this is for me, for the code, for the letters, not only the numbers, but the letters. مش كده؟ طيب. What is the disadvantage of those non-binary number representations? They are all representing integer values. مش كده ولا ايه؟ تمام؟ They are all full integer. Whether you are talking about unsigned numbers, signed two's complement, or signed magnitude, those are only for integer numbers. Do you deal only with integer numbers, or you also deal with real numbers, the numbers with fractions? صح? I want to shock you. What we have learned in assembly so far, all the instructions that we have learned from the beginning of the semester till now was, if you go and reflect on them, you will find them all integer numbers. But in real life, do I have only integer numbers? Definitely no. I actually have the real numbers. What are the real numbers? The real numbers as the numbers with fractions. We deal with the numbers with fractions in DLD. مش كده ولا ايه؟ تمام؟ تعاملنا مع ارقام real numbers في DLD. But the representation that we have used to represent real numbers in DLD is usually called a fixed point representation. In order to represent the real numbers, I have two ways. Either fixed point representation, or what we will be learning today, which is called the floating point. What is the fixed point representation? Fixed point representation assumes that the decimal point is fixed. يعني I want something to discriminate for me between where is the integer part of my number and where is the fractional part of the number. مش كده ولا ايه؟ How can we discriminate between the integer part of the number and the fractional part of a real number? We are using a dot, we call it the decimal point. مش كده ولا ايه؟ صح؟ كله متابع؟ كله مصدق؟ تمام؟ You learned how to deal with the real numbers in a fixed point representation, okay, in DLD. صح؟ مش كده ولا ايه؟ يبقى السلايد 5 that we are showing here is actually show me some. يبقى الاولاني ده كان integer. التو numbers here اللي هم 16.75 وال 0.125 are real numbers ولا مش real numbers؟ Those are real numbers. So in order to know that this is a real number, we use what's called the decimal point. The decimal point actually separates between the integer part of the number and the fractional part of the number. Right. Can we use this for binary? The answer is yes. If I am representing those numbers in binary, how we usually do? We learned that in DLD. Okay? We طبعا ايه؟ حد لسه فاكر؟ الانتجر recursive division والfractional recursive multiplication until I reach to this format. يبقى these are the equivalent numbers in binary for decimal. يبقى the first thing that we need to review from DLD is how can I convert a decimal real number into real number in binary. تمام؟ Go and review that because we need that in this chapter and in this chapter بس till the end of the semester we will be using that. So I highly encourage you to go and review this information. طب can I represent 16.7 in binary? Yes. أهي. Can I represent minus 16.75? Yes, also. All what I have to do is to get the 2's complement of the fixed point binary representation. يبقى fixed point can be used for positive and for negative, or I can use the 2's complement to represent the fixed point representation. And the fixed point representation is for real numbers. What do we mean by fixed point? Fixed point is that, remember something, we are talking about binary. We are talking about storage at the end of the day. This number is stored somewhere, either in a register or in the memory inside the computer system. صح ولا مش صح؟ مش كده ولا ايه؟ At the end of the day, in order to put this number, it will have some storage. And this is storage is binary storage. مش كده؟ في some slots. Okay? So if I am storing a number, I have to clearly indicate where is my decimal point, where are the part of the storage I dedicated for the fractional part, where is the storage that I have for the integer part. Okay? To make the demonstration easier, I will assume that my storage here can carry in decimal numbers. تمام كده؟ طبعا in the computer system احنا عارفين ان احنا we cannot store anything except binary. بس للتسهيل عشان اشرح الكونسبت بتاع الريل نمبر ريبريزنتيشن سواء كان fixed point او floating point, I will use the decimal, assuming that the storage in the computer system can carry decimal numbers. تمام؟ حلو الاتفاق ده ولا وحش؟ حلو. ليه حلو؟ Because it will make the concept easier for you to understand. Then we will shift to the binary. حلو الكلام؟ اتفاق حلو. Shall I move on? يبقى طيب. Assume that I have a storage of 8 digits. Okay? What will comes first to your mind? Okay? To actually split now الستورج بتاعي فيه 8 digits. مش هسميهم 8 bits لان انا هنا مخزن فيهم I'm using them to store decimal numbers. تمام؟ decimal digits. فعشان كده I'm calling them I'm calling them an 8 digit storage. If you have 8 digit storage, so intuitively you will say, okay, for the fixed point representation, I should well define where is my decimal point. And intuitively, I will have, as the slide showing here, شايفين السلايد يا شباب؟ كله شايف السلايد؟ ها؟ السلايد هنا بيقول لي how many digits are to store integer and how many digits are to store the fraction. صوت صرصور الحقل مفيش حد خالص محدش بينطق. The slide that we are showing here, slide 6, each of them أخيرا حضرت شكرا جدا يا رغد. Okay, I have 4 storage, 4 digits to store the fraction and 4 digits to store the integer, and it is clearly shown that my decimal point in the middle of them. طبعا in the real storage we know that the decimal point is in the middle. We don't have to have something to store the decimal point, but it is an agreement that we have 4 storages for the integer and 4 storage for the fraction, as we can see here. تمام؟ يبقى total storage that you are using here is how many? Is 8 digits, storing 8 digits. 4 of them for integer and 4 of them for the fraction. This storage fits the number that I'm showing here very well. Okay, can you see the number here that I'm storing? The number is 94.53. Okay, مش كده ولا ايه؟ This number can fit in my storage very well. مش كده ولا ايه؟ صح؟ اوكي. الانتجر part فيه the values 4 و9 وبعدين 2 zeros, and the fractional part have the values 5 with 3 and 2 zeros. Everything looks healthy, everything is perfect. تمام؟ Agree? The next thing that we need to notice here, how many real digits or the meat of this number contains how many digits? What is the significant digits in the number? ايوه كده بالظبط يا عبد العزيز. 4 بس اللي هم مين؟ ال9 وال4 وال5 وال3. يبقى النمبر actually okay has 4 significant digits. The storage has 8, 4 for integer, 4 for fractional, and I just extend the rest with zeros. صح كده؟ جميل. طيب. Is this a good way to represent? This is what we call the fixed point. Fixed point means I have some storage for integer, I have some storage for fraction, and I'm just storing the integer, and the fraction in the fraction, and that's it. Well, point is fixed in the middle of them, or maybe not in the middle. It could be even biased. It depends on I lean towards the more integer numbers or more fractional numbers. This representation has a very big disadvantage. A disadvantage, okay? It cannot represent 2 big numbers or 2 small fractions. The examples here, okay, in this slide, okay, will demonstrate that. Can you see the next number that I'm showing here? Can you, the second number that I want to represent here is 9,300. يبقى 945,300. Can I represent this number in my fixed point representation that I have here in these 8 slots? The answer is no. I cannot, because actually to represent or to store this number, I need the integer part to have at least how many slots? How many slots do I need for the integer part to store this number? I need 6. I need 6. This number cannot be represented here. Right. Let's go to another extreme. What about 0.0009453? Can I represent this number in my storage here? The answer is yes, because actually I can have for the decimal point here, I can store it as 0009, but I'm losing significant amount of accuracy of the number. A number is actually rounded. I have lost the small fraction of 0.000453. كل ال 453 خسرتها. يبقى I'm losing high accuracy. Okay? This actually motivates changing representation of real numbers in the computer system from a fixed point to what we will be explaining momentarily. Okay? A fixed point representation is a poor representation. Remember something, for the three numbers that we just talked about, the digits of the numbers are only 4. And even with 8-digit storage, I cannot store the number because large numbers, significant number, or small fractions cannot be represented, while the number itself has only 4 significant digits: 9 4 5 3. Okay? And here is the magic. So what the engineers have decided to do is to use what's called a floating point representation. Can we make the decimal point floating? Okay, this needs some work, because in order to indicate the location of the point is not easy. So the mathematicians have think differently. The numbers, the three numbers that we can write here, can actually re-represented as follows. Okay, follow me here. We are in slide number 8. Can you see the three representation, the new representation for my three numbers here? The first number can be written, instead of writing it as 94.53, I can write it as 0.9453 multiplied by 10 to the power 2. صح ولا مش صح؟ agree ولا مش agree؟ يبقى هنا this is what we call the scientific notation. مظبوط يا عبد الرحمن. Okay? This we call the scientific notation. طب what about the second number? The very big number. Okay? Remember something, it has the exact same digits as the first number, but I can scientifically write it as also the same number but multiplied by to the power of كام? To the power of 10 to the power of 10 to the power of 6. مش كده ولا ايه؟ Agree? But what about the last number? The last number can also be, we can do the same thing, okay? But we have to raise the powers of 10, the 10 to the power of كام? We can raise the 10 to the power of كام here? We have to raise the 10 to the power of -3. Do you agree? تمام؟ طيب الانجينيرز والماثيماتيشنز بقى find it a brilliant idea. Okay? Now comes the idea of the floating point. Now, actually representing those numbers needs only to store the real meat of the number, which is the 9453, assuming that the decimal point to the most left of the number. ايه رأيكم كده؟ تمام؟ But in order to fully have the exact same value of the number, instead of writing or storing 10 to the power, all what I have to store is the powers of the 10. Can you see that? So instead of using my storage to store the number as integer and fraction, I think differently. Right now, I will utilize my storage to store the meat of the number, or the digits of the number, and the powers of the 10. Okay, I will use the, as Abdurrahman have mentioned, the scientific notation of the number to be stored in my storage. Right now, I will store my first number as 0.9453. Okay, يبقى ال first four storages here will store the meat or the digits of the number itself. We call it the mantissa. And the four other storage will be used to store the powers of the 10. ال 10 مش هتظهر خالص عندي. اوكي؟ ال 10 انا مش محتاجها لان I know that I'm storing a decimal number. And what I really want to store is the powers of the 10 to indicate or to know what is the value of the number. At the end of the day, I am looking for the value of the number. From this representation, can you retrieve the original number ولا لا? Can you retrieve the original number or not? You can. You know that the significant, the digits of the number are fractional. Okay, we call it the mantissa, and we know the exponent part, which is the powers of the 10. In order to retrieve the value of that number, I will let you go retrograde. Write the 0.9453 multiplied by 10 to the power 2, I can get the number, my value of the number back. مش كده ولا ايه؟ طيب. What is the beauty of this representation? The beauty of this representation, since I used the number, I store the number as mantissa and the exponent, magically, surprisingly, right now, the two numbers that we failed before to store can be now stored in my 8-digit storage. Okay, now this big number, if I write it in this notation, I can simply take the digits of the number, store them here in the mantissa, and I will take this 6 and store it in the exponent part here. Did I succeeded to write the very big number or not? Did I succeeded to write the big number or not? Yes, I do, because right now I have the meat of the number, which we call it the mantissa of the number in its scientific fractional notation, and all what I need is the powers of the 10. I'm storing the number not as an integer and fraction, I'm storing the number, I'm utilizing the exact same 8-digit storage, but as a mantissa and the exponent. This allows me to store the original number, the very big number, and also the very small number. This representation is called what? It's called floating point representation. Because right now, the decimal point is actually virtually floating. Virtually floating. Because actually the exponent here indicates that although the number looks to be just a fraction point 9543, but actually the exponent here raised the powers to positive or negative powers to allow the number to be either big or small, all integer or all fractional, or something in the middle. Agree? Make sense? حد فهم حاجة؟ Clear? تمام؟ يبقى from now on, we are not storing real numbers as integer and fractions. We will use a new representation, اسمها ايه؟ floating point representation. Okay, so if I'm asking you to represent this number for me in floating point representation, you have to first do an operation called normalization. What is normalization? You have to represent the digits of the number as all fraction. Okay? In all fraction, this number actually requires the storage of CAM of 7 digits. Okay? If 7 digits should be used for the mantissa of that number. And only 1 digit is needed for the exponent of that number اللي هو 4. صح؟ Agree or not agree? Okay? You can imagine here that I need more storage for the mantissa than the storage for the exponent. Because actually, with a little bit or with a little storage of the exponent, I can represent very large numbers. And in order to keep or storing or allowing significant number of digits for the number, I need the mantissa to have much more storage than the exponent. Agree? Make sense? Clear? Remember something. We explained all of this to demonstrate to you, to make the idea clear for you in the decimal. Okay? Okay? We will now shift to the binary. Before we shift to the binary, we can actually here representing or showing that you see this very big million numbers. Okay, this number can impossible be represented in the floating point or the fixed point, or it needs too many digits in order to store the number. Okay, we as our daily life, you will never when you want to when you wanted to store this kind of number, do you ever write it like this? No, we usually write it like this. We maybe write it a 9.76 multiplied by 10 to the power 11. Okay, you can see here, even in pen or paper, okay, you are consuming less space to store the big number. مش كده ولا ايه؟ صح؟ Okay, so this is actually the idea. This is the trick. Agree? Make sense? حد فاهم حاجة؟ يبقى now the two pieces of the number are mantissa and exponent, not integer and floating. Okay? Here is another example. Okay? So assuming that I want to represent this number in the floating point representation, the first thing to do is to normalize the number. What normalize means? You have to shift this decimal point to the most left. Right. How can I shift it to the most left? بيحصل ايه في الرقم لما نشفت الديسيمال point to the left? The powers of 10 is going up or going down? Am I incrementing the powers of 10 or decrementing the powers of 10? This is very important to know. مين شاطر يقول لي؟ Incrementing. Incrementing by how many? Increment the number of shifts that you do to the number. But if I want to represent this in the floating point, or what you call scientific notation, okay, I am shifting this how many decimal point to the left, how many places? 4 places. This automatically raises the number, the 10 to the power of CAM to the power of 4. If shifting the decimal point to the left, incrementing the powers of 10, each shift incrementing 1, each shift incrementing 1, each shift incrementing 1. Okay? يبقى actually I will store 1, 2, 3, 4, 5, 6, 7 in the mantissa part, and I will store the small 4 number in the exponent part. Right. How this will be different for the binary? I think we are already exceeding the time. It's now 10:48, and we will stop here, and we will continue discussing the floating point representation and the standard of the floating point in binary in the next lecture, inshallah. Okay, but at least we have get the idea of what's the floating point. If a floating point is storing number as mantissa and exponent, instead of storing it as integer and fraction. Definitely you cannot tell the value of the number from the representation of the number. You have to do some mathematics. Take the mantissa, put a decimal point for it, take the exponent, raise it to the power in order to retrieve the value of the number back. We will continue that inshallah in the next lecture, the floating point representation in binary and what is its standard that is used in our computer systems, inshallah next lecture. Okay? Any questions؟ حد له أي سؤال؟ حد محتاج مني حاجة؟ خلاص يبقى this lecture is recorded. I would like to thank you and we will stop the recording here and the video will be available as usual. Thank you يا شباب.